So in this example, we're going to do example 6. I'm going to start by getting a common denominator in this first part here because it would make it a lot easier to FOIL out when I have to do that part. So I know if I have 1 over 1, that if I want my common denominator to be n, it would make it an n up there. So I'm going to have the limit as n approaches infinity of the sum of I, I'm going to keep wanting to write an n there, of I equals 1 to n of n plus 2I over n, and we're going to square that times 2 over n. Now I'm going to go ahead and FOIL this piece here, okay, which means I'm really writing the limit as n approaches infinity of the sum of I equals 1 to n of n plus 2I over n times n plus 2I over n times 2 over n. So I know my definite denominator of this whole thing is definitely n cubed. So I'm just continuing to write all that mess out. So I know I've got an n cubed in the denominator. N times n would be n squared. N times 2I would be 2in, but I have 2 of those, so I'm going to have 4in. And then, yeah, okay, making sure I'm doing it right. And then we're going to look at I'm making sure I'm doing this right, sorry. No, I'm looking at the wrong one. Yep, okay, I'm on the right track. I was looking at the wrong piece of paper. Okay, and then 2I times 2I is 4I squared. And then we just have it multiplied all by 2, okay? So next I am going to go ahead and take out this piece right here, okay? So I'm going to take that out in front. So the limit as n approaches infinity of 2 over n cubed, the sum as I equals 1 to n of n squared plus 4in plus 4I squared. So from there, we know that we can replace this one and this one with the special formulas, okay? So, and then remember, I could break this up. So this here is acting like a constant. So this is a weird step. So since it's acting like a constant, remember it's a constant times n. So when I'm multiplying that constant times n, I'm going to get n cubed. This stuff here is just going to stay out front. And then this one here, I'd have a 4n already. And then I'm going to, the I, remember, turns into n times n plus 1 over 2. So that's that term. And then this is going to turn into the plus 4. The I squared turns into n times n plus 1 times 2n plus 1 all over 6. Now, again, when we're looking at this, we want to look at the coefficient of our biggest exponent. And it looks like I'm getting cubes kind of all over the place, aren't I? So let's just look at what the coefficients would be on our cubes. Okay. Actually, they went and did some common denominators. That's not going to make... yeah, it is going to make a difference. Okay, so before I can add those together, I know I have to make common denominators. So that's the next step. And I'm going to use a common denominator of 6. So the limit as n approaches infinity of 2 over n cubed. So I know that this is 1 over 1, so that's going to become 6n cubed over 6. Plus this one here, I just have to multiply by 3. So that would be 12. And look at what's happening here. N times n times n is going to be n cubed. And then 4n times 1 would be 4n squared. Not that I even care about that part, all over 6. Actually, that would be 12n because I missed the distributing that extra 3. So it would be 12. Okay. Then I am going to, I really only care about the n cubed term, so I'm only really going to mess with that one. This one's already where it needs to be. So I know I've got a 4. We know we've got the 6 in the denominator. We have n times 2n would be 2n cubed plus a bunch of other junk, right? Whatever that FOILs out to be. So I know that I for sure have, I could factor that 6 out of the denominator. So that would be more like, I'm going to bring that up with this here. So the limit, just so we can see it a little bit better. So we've got 2 over 6n cubed times 6n cubed plus 12n cubed. I'm going to bring this up here. That would be 8n cubed plus a bunch of other stuff. Okay, so I'm only concerned about the cubes. Now, I know I've got cubes on the top, cubes on the bottom, so I'm going to take the limit of the coefficients. So the limit of my coefficients, and I'm going to take, this is part of it, so it would be 2 times 6, no, times, not times 6, times 6, plus 12 plus 8 all over 6. So that's going to reduce to 3. When we add that up, we should get 26 over 3 would be our limit.